On this Sierra, P0128 means the ECM may be seeing engine coolant temperature stay below where it expects thermostat regulation to be. In plain terms, the engine may not be warming up the way the ECM expects, or the temperature information may not be believable. The driver may notice a check engine light, the cooling fan can be commanded on, and warm-up behavior may seem off. Broadly, keep your mind on possible coolant level or coolant condition problems, thermostat operation, coolant temperature sensing, and the signal or low reference circuits. Before getting deep into testing, start with the basic system checks and follow a structured diagnostic approach. If other codes are present, especially around coolant temperature, radiator temperature, or coolant bypass control, understand those first, instead of treating P0128 in isolation. The ECM uses engine coolant temperature for engine control and as an enable for some diagnostics. P0128 sets when measured coolant temperature does not reach thermostat regulating temperature before the expected amount of airflow has gone through the engine. On a warmed-up engine, the ECT sensor normal range is listed as 88 to 105 degrees Celsius, 190 to 221 Fahrenheit. The scan data also gives you circuit clues. A signal short to ground can show 150 degrees Celsius, 302 Fahrenheit. An open can show minus 40 degrees Celsius, minus 40 Fahrenheit, and a short to voltage can also show minus 40 degrees Celsius, minus 40 Fahrenheit. The signal input circuit has internal resistance connected to 5 volts, so use those scan values to decide whether you are chasing thermostat warm-up or an electrical signal problem. When you reproduce the monitor gate, the startup ECT range is minus 40 to 56 degrees Celsius, minus 40 to 133 Fahrenheit. Engine off time is greater than 30 minutes, engine run time is 30 seconds to 37 minutes, and fuel alcohol content is less than 87%. One useful sanity check: after the ignition has been off for greater than 8 hours, intake air temperature and engine coolant temperature should be within 3 degrees Celsius, 5 Fahrenheit of each other. Also remember, high resistance and related circuits can set P0128 even when a separate component code is not set. First, verify there is no incorrect fluid level or fluid condition. If that condition exists, repair or replace as necessary before continuing. If the coolant level and condition check passes, verify there are no related codes for the engine coolant temperature sensor, the radiator coolant temperature sensor if equipped, or the engine coolant bypass valve if equipped. If one of those related code paths is active, check what that code means first, and handle that path before continuing with P0128. If not, continue with the thermostat check for P0128. For the thermostat verification, runtime needs to be greater than 10 minutes. Slowly bring engine speed up to 3000 RPM, and keep the air conditioning off. Watch the ECT sensor parameter. It should get greater than 85 degrees Celsius, 185 degrees Fahrenheit within 5 minutes. If it's 85 degrees Celsius, 185 degrees Fahrenheit or colder, test or replace the engine coolant thermostat. If it's warmer than 85 degrees Celsius, 185 degrees Fahrenheit, reproduce the operating conditions for the code, or reproduce the captured conditions if that information is available, and confirm whether P0128 resets. If it does not reset, the result is all okay. If it resets, move into circuit testing instead of guessing at the thermostat again. For circuit testing, turn the ignition and vehicle systems off. Disconnect the B34 engine coolant temperature sensor and give the vehicle systems time to power down. It may take up to 2 minutes before a ground or low reference continuity test is accurate. Test between low reference terminal 1A and ground. You want less than 10 ohms. If it is 10 ohms or greater, disconnect the K20 engine control module and test the low reference circuit end-to-end. That end-to-end check should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the circuit. If it is less than 2 ohms, the path calls for replacing the K20 engine control module. If the low reference test is less than 10 ohms, turn the ignition on with the vehicle in service mode. With the B34 sensor disconnected, the scan tool ECT sensor parameter should read colder than minus 39 degrees Celsius, minus 38 degrees Fahrenheit. If it is minus 39 degrees Celsius, minus 38 degrees Fahrenheit or warmer, turn the ignition off, disconnect the K20 engine control module, and test the signal circuit for a short to ground. You should have infinite resistance from signal terminal 2B at the component harness to ground. If resistance is less than infinite, repair the short to ground. If resistance is infinite, the path calls for replacing the K20 engine control module. If the disconnected sensor reading is colder than -39 degrees Celsius, -38 degrees Fahrenheit, install a 3 amp fuse jumper between signal terminal 2B and low reference terminal 1A. Now, the scan tool ECT sensor parameter should read warmer than 149 degrees Celsius, 300 degrees Fahrenheit. If it does, test or replace the B34 engine coolant temperature sensor. If it is 149 degrees Celsius, 300 degrees Fahrenheit or colder, remove the jumper and keep testing the signal circuit. When the hot simulation does not pass, remove the jumper. Leave the B34 disconnected. Disconnect the K20 as directed and turn the ignition on with the vehicle in service mode. Test signal terminal 2B at the component harness to ground. The voltage should be less than 1 volt. If it is 1 volt or greater, repair the short to voltage. If it is less than 1 volt, turn the ignition off and check signal circuit continuity from the component harness to the control module harness. That resistance should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the signal circuit. If it is less than 2 ohms, the path calls for replacing the K20 engine control module. For direct component testing, turn the ignition and vehicle off and disconnect the B34 engine coolant temperature sensor. Measure between signal terminal 2B and low reference terminal 1A. The sensor should be between 42 and 78,834 ohms. If it is not in that range, replace the B34 engine coolant temperature sensor. If it is in that range, compare the measured resistance against the correct temperature versus resistance range for the sensor. If the value is not in the specified range, replace the B34 engine coolant temperature sensor. If it is in range, test from each sensor terminal to the sensor housing. That should be infinite resistance. If it is less than infinite resistance, replace the B34 engine coolant temperature sensor. If it is infinite resistance, the component test result is all okay. After the repair is complete, verify the repair and confirm the code stays gone. Keep the verification separate from the testing path. Prove the fault is corrected under the operating conditions that matter, and do not call it fixed just because the code cleared once. The takeaway on P0128 is simple. Confirm coolant condition first, prove thermostat warm-up. Then use sensor simulation and circuit checks to separate a thermostat problem from an ECT sensor, wiring, or module side fault. For more diagnostic training, visit stepdiagnostics.com.